Hi friends, good morning. Today we are focusing in some problems based on the last lectures. Last lecture we seen some operators in vector analysis like curl, divergence, gradient, that will be seen. Alright? Okay, let us go to the first problem. See, find the gradient of a function v, where v of x, y, z, x square y plus e raised to z, right? Calculate the magnitude of gradient at the point 1, 5, minus 2, alright? So, what is gradient function? Right. So, gradient is equal to magnitude of gradient, that means gradient A is equal to what we studied I cap. So here V is given, so let me use the letter V. Alright, gradient V is equal to I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. This is our del operator and a function acting on it, that is x square y plus e raised to z, right? Now here, with respect to x, when we differentiate, keep y as a constant. That means on doing this function, what you get, that is equal to 2xy, right? 2xy I cap plus, right, with respect to e raised to z on doing 0, right? Y keep constant, x square on doing 2x. Now again do this one with respect to y, here you get x square j cap, right? E raised to z on doing with respect to y, that is 0 because z is a constant. Now again with respect to z you do this constant, differential of e raised to z is e raised to z k cap, alright. Now let me substitute this value 1, 5, minus 2, right? So 2 into 1 into 5, right, I cap plus x square, that is 1 square j cap plus e raised to minus 2 k cap. So that is equal to, right, 2 into 1 into 5, that is 10 I cap plus j cap plus e raised to minus 2 k cap. Then if you take magnitude of this gradient v, what I get? That is equal to square root of 10 square plus 1 square plus square of this, that is e raised to minus 4, alright? Alright. Now let us go to another question, right? Find the unit vector normal to the curve y is equal to x square at the point 2, 4, 1, right? So to find the surface equation given, curve equation given. So if equation is given, what is the direction of normal vector? Gradient of that particular function, right? Then function of this curve, how we find, alright? So we can find our function as phi is equal to x square minus y, alright. Then this y taken to here, that is the function, alright. Now what is gradient phi, right? So we want to find a unit vector normal to the curve. That means what is the unit vector? The direction of normal vector is gradient phi. Then to find unit vector divided by its modulus, alright. So what is gradient phi? Gradient phi we can find I cap dou by dou x. See, gradient phi is equal to I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Then phi acting on this del operator, that is x square minus y, alright. That means I cap the x square on doing 2x, y on doing 0. With respect to y, if I do that is minus 1, then minus 1 j cap, and with respect to z, no z component is here, then 0. Then 2x I cap minus 1 j cap. Alright? Alright. Now substitute these values here. That means 2x I cap minus j cap divided by its modulus. That means root 2 square plus minus 1 square. So this is the unit normal vector to this curve. Alright. Now let us go to another problem. Given a vector A, right, given a vector A is equal to x plus c1z x cap plus c2x minus 3z y cap plus x plus c3y plus c4z z cap. Right. A vector field is given. What we want to find is calculate the value of constants c1, c2, c3 if A is irrotational. What is irrotational? It is not rotating. What is the rotation of a vector function? Del cross A. So if it is not rotating means del cross A is 0. Right? So del cross A is 0, equate and find out the constant. That only the question. Right? So irrotational means it is not rotating. That means del cross A is equal to 0. Now another condition is there, solenoidal. If a function is solenoidal means it is not diverging. It is not a diverging. That means divergence of that function is 0. That is div of that function is 0. Alright. So let us do the first question. See, let me take here a second question is regarding find the constant C4 if A is solenoidal. Alright. Alright, let me take this question. You can take to this question into a plain board. Alright. A is equal to, let me take this A. Right. Now what is, if it is irrotational means del cross A is equal to 0. Alright. Del cross A is equal to 0. That means what is del cross A? I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z. Right? See, I am writing this k cap here. Right? What is x cap component? X plus c1 z. Right? c2x minus 3z. Right? c2x minus 3z, right? Now x plus c3y plus c4z. So this is equal to 0 given. Now expand this I cap into, what is this? With respect to y, I get a c3, this is 0. With respect to z, here I get a minus then plus 3z, right? Plus 3 minus j cap into, right? So with respect to x, here I get a 1, the remaining two terms 0. So I have minus j cap only. Alright? Alright. Minus j cap only. So sorry, minus j cap and this also, right? That is with respect to dou by dou z of this is 0 and here plus 3. Alright. This is 3z. So differential of this is plus 3. Alright. Plus k cap into, alright, plus k cap into here, right, C2, alright, here minus with respect to y 0. Now directly you can write it. If this is 0 means C3 should be minus 3. So C3 is minus 3. And what about C2? C2 is equal to 0. Alright. And here this is minus 3z. And what about C1? So I cap dou by dou y. C1 is not coming here. Here also C1 not coming. Minus j cap into this dou by dou x of 1, right, 1 only coming, minus, yes, here this is actually C1z, I am sorry, C1z, then this minus this, so whatever we get is C1 only we get here, I am sorry, right, then C1 should be minus 1, C1 should be minus 1, alright. So solenoidal means div A is equal to 0. So what is solenoidal condition? Solenoidal means divergence is 0. That means solenoidal means the quantity is not diverging. That means divergence is equal to 0. Right? Now look here. Divergence of this is 0 means, so differential of what is divergence equation we studied? Dou A x divided by dou x plus dou A y divided by dou y plus dou A z by dou z, that is equal to 0. Alright, that means differentiate this is x, this is a y, this is a z. Alright, if that is equal to 0 means here differential of this is 1. Alright, 1. Correct? Dou Ax component on doing, this is 1, x on doing 1, here not affecting, and here no y component, then this is 0, here on doing C4 only coming, then C4 is equal to minus 1, alright, this should be equal to 0, then C4 is equal to minus 1, alright. Now determine the scalar potential of the function V whose negative gradient equal to A, alright. Then again we need this question, right. So I need this function, right. Here determine the scalar potential function V whose negative gradient equal to A, alright. So minus dV by, right, negative gradient how we represent? We can represent a negative gradient, right, of V minus del V equal to A given, right, then minus I cap dou by dou x, right, dou Ax by dou x, j cap dou Ay by dou y plus k cap dou Az by dou Z, alright. This is equal to this vector, that means you equate with this, then definitely you know this part should be equal to, negative of this part, that minus dou Ax by dou x is equal to this x plus C1 Z, x plus C1 Z, right. Then by integrating what you get? So integrate this, we want to find this Ax, Ay, Az, right. So this you can write as this is Vx. Why I am writing Vx? They named this function as V. Then you take this as V, right, Vx, here you can take Vx, here you can take Vy, here you can take Vz, right. Then what is Vx? Vx is equal to what I can write? That means minus of, integrate this side. With respect to x, you integrate x square by 2, right? Alright. C1 z with respect to x, C1 z x, right? Now similarly, you find the next minus dou a y by, vy divided by dou y equal to this part, that is C2x minus 3z. Alright. Now what is Vy? Integrate again. With respect to y, here C2xy, 1 minus is here, this minus minus become plus, then what is remaining? That is 3yz. 3yz. Alright. Alright. Now what is Vz? Next term you take. What is that? That is dou Vz by dou z, right? So here I am not doing. So next part, dou Vz by dou z, that is equal to what I can write, x plus C3y plus C4z. Alright. Now what is Vz? This negative gradient you should take, right? Alright. So Vz is equal to what you can write? That is equal to minus x square by 2, right, plus here C3yz, C3yz plus C3yz, that means minus also come here, then this is minus. Next is C4z square by 2, minus C4z square by 2. Now Vx, Vy, Vz you seen. Now here minus x square by 2 is there, then our full function is first one minus x square by 2. That is coming here and here. So common we cancelling, right? Now C3yz, that is different. Here 3yz, so minus C2xy, this we cancelled. Here 3yz plus 3yz, so this also we cancelled. Now in this term minus C1 zx is there, minus C1 zx, right? So this also we cancelled. Then C3yz, alright, that is plus C3yz, so that is minus y, here this minus come here, so minus C3yz, alright. Now minus C4 by z square by 2. So this is that function, alright. This is that particular scalar function, alright. Alright. So this about this section. We will do more problems after the completion of lesson. Okay. Thank you.